The next program is the rotation of the probe, and this program and the next program is almost similar. And let us look at the program. Initially, glut init specifies the initialization of a program with the graphics utility toolkit. Glut init display mode. So this will initialize the glut single, which will use a single buffer and set the RGB mode. Glut init window size. This sets the window and the height of the window. Glut init window position. It will set the position of the window top left corner. Glut create window, a basic OpenGL window. Set the caption for the window. Glut display function. It is to display the content what is to be displayed on the screen by calling the display function. Glut main loop initialize the GL loop cycle. GL clear color. It will clear the background. It will clear the background color of the window, and it is black here because it is given 0 0 here 0 0 0, so it will become black. Now GL clear, it will clear the color buffer. Load identity. It will set the identity matrix and reset the previous matrix by setting identity matrix. This is OpenGL libraries. GL specifies the lowest level. It keeps track of vertex matrix manipulation, and one of the example is GL vertex. GLU. This is the helper function, which is like it has GL look at function. It is a helper function for shapes like transformation. Glut. It is the highest level, so it is window interface management. For example, glut init window size. Let us look at the program. First part of the program, then now let us look at the program again. So here we initialize the vertices. Here we initialize the vertices, and here the colors. And here we draw the polygons, and the polygon function is called here color cube, and display the how you're going to display the polygon, that is the cube, and it is rotated based on the angle that is specified and which angle that is to be rotated, x-axis, y-axis or z-axis. And this is where you specify which axis that is to be rotated. If it is x, that is 0, that is x-axis. 1 means y-axis, 2 means z-axis. And the theta is incremented, that is the angle, with 2 degrees every time it is rotated. And this is the viewport, that is reshape port. It is ortho is left minimum, right minimum, left minimum, right maximum, and y minimum, y maximum, and near and far. So this is the height and width of the orthogonal display. And the projection matrix we are going to specify, and the viewport under which the polygon or the cube that is to be displayed. And this is the main function. This part we have seen in the code, that is initialize function. Glut init display mode, glut create window, that is the color cube, glut reshape function, glut display function, glut keyboard for keys, enable and clear the color with background 0, and the main loop. Let us look at the cube. So this is how the cube as the vertices that is will be displayed on the screen, and whenever the screen is taken in 3 dimension, and the 0 is here, and z-axis, x-axis and y-axis, and the 0 is at the center, and the z-axis, x-axis and y-axis. Now let us take the vertices. So initially let's consider -1 and -1. So x is -1, y is -1 and z is -1, that is 0. And seen in the screen the 0 is here. So it will be -1, -1 and -1. And then next 1, -1 and -1. It is here 1. 1, -1 and -1. So that this will be 1. And next 1, 1, -1. So that is here. So this will be 1, 1, -1. So that is 2. That is this part. And -1, 1 and -1. -1, 1 and -1. So that is this part of the polygon. And next vertex is -1, -1 and 1. So this is here -1, -1 and 1. That is 4. So this will be -1, -1 and 1. The next vertices is 5, and here 1, -1, 1. The 5 is here, this part. Okay, next vertices is all 1, 1, 1. That is the sixth vertex. This is the vertex. This vertex is 1, 1, 1. So this will be 1. So that means z is 1, x is 1 and y is 1. And the last one is -1, 1 and -1 and 1. So this is -1, 1 and 1. So that is this part. -1 is because it is going -x. It's going -x. And 1 is because it is going y, positive 1, positive y. And then positive z. Now let us look at the color cube. That is the function that is called all these polygons. So all these polygons are called with the vertices, and you can see these polygons called with the vertices 0, 3, 2, 1. It is called 0, 3, 0, 3, 2 and 1. This is the polygon that is called. And next polygon is 2, 3, 7, 6. It is 2, 3, 7, 6. Next polygon is 0, 4, 7, 3. 0, 4, 7 and 3. Next polygon is 1, 2, 6, 5. 1, 2, 6 and 5. Next polygon is 4, 5, 6, 7. 4, 5, 6 and 7. Next polygon is 0, 1, 5, 4. 0, 1, 5, 4. Now let us look at the rotation of this polygon, of this cube. So the cube formed using polygon, now it is to be rotated. Now there is a built-in function that is called GL rotate F, and it specifies theta, that is the angle, and 0 represents x-axis, and that is 1. Theta 1, that represents y-axis. Theta 2, that represents z-axis. So this is the rotation about the axis. Now based on the theta is increased, the cube is rotated. Now, so this is 0. 0 means x-axis. Axis 1 means y-axis. Axis 2 means that is z-axis. Now let us look at the rotation of this cube. Now x-axis, that is axis 0 is selected and it is rotated in x-axis. This is x-axis. Now the next 1 is selected, axis is equal to 1 and it is rotated in y-axis. Now the axis 2 is selected and is rotated in z-axis. Next, the color cube is formed, and this is how it looks like. The rotate function, with an angle theta and rotated with the x-axis. And here, when it is rotated with the x-axis, that means the axis x becomes 1. This is and the y and z are changed. So with an angle of theta. Here it is rotated y axis, that means y becomes 1, and it is rotated with an angle of x and z. And z axis, z becomes 1 and rotated with x and y. So that is what. That is why we have 1 here, and here 1 for y, and here 1 for z. Now projection matrix. The cube we have formed, it is in this form. Now how is the projection matrix is defined? The screen that you are looking at is from here, and the projection is positive z, y, positive x. So that's the projection. Now the -1, -1 and -1 is projected in this form. So when it is projected, so you have here -1, -1 and -1. So it is the -1 is the left part. Okay, so it is positive y, z and x. So it is the left part, it comes here, and the cube that is formed, you can see here. This is how the eye is here, and you are looking at the screen, and you have the cube that is being formed. So here the -1, 1, -1, 1, 1, -1, and this becomes -1, -1 and -1. This is the projected one. And this is the first cube, that is 1, -1 and -1. This is this one here, it's coming here. This is projected here, this is projected here, and the y, -1, 1 and 1. So is the front part of the cube, -1, 1 and 1, that is this part. This is coming here, and then this one 1, 1, 1 is projected, and the screen that is seen, the blue color is the front side and the red is the back side. So here the cube that is from the 0, 1, 2 and 3 are the back part of the cube that is seen, and 4, 5, 6, 7 are the front part of the cube that is seen. And now if it is x is selected, axis is 0 and it is rotated in an x axis, and y is 1, y is selected and axis is 1, it is rotated in y axis. That means y becomes 1 and the angle theta is given to x and z, and it is rotated with z axis by specifying z, and axis is equal to 2 with an angle of theta of 2 degrees and increment. And you can look here, this part is the orthogonal, or x minimum, x maximum, y minimum, y maximum, near and far. And the final output we would look at is, this is the final output. So if x is selected, now it is rotated in the x axis, and the vertices, here the vertices is the vertices which having the color, and the color is changed when it reaches the other vertices. So each vertices is given, this is rotated in y axis, and now this is rotated in z axis. Thank you.